Good morning. Today I'm going to talk about this worksheet, Early Atomic Structure. Now, it's only recently that we've been able to determine what subatomic particles make up an atom. There was a lot of speculation, even back in ancient times, but until we had more modern scientific equipment, we didn't know. We couldn't get good evidence. So in about the 1800s, late 1800s or so, one of the early experiments that gave us some information was this thing called a cathode ray tube. And in the cathode ray tube, what we have is a tube here that's sealed. It has some gases, not a lot. You can put different gases in here, but a low pressure, so not a lot of gas particles. And this is hooked up to like a battery. So it'll send a current here through this loop, okay? When it does that, the cathode ray tube here has a metal plate on this end and a metal plate on this end. And there's nothing connecting the two metal plates. But when you pass electricity through here, you get this stream that usually would go straight across. This green stream would go straight across and it would glow. Now it's glowing because of the gases that are in the tube. So what we find out is that this stream is a stream of electrons. Now they didn't have the name for electrons yet. This is what they would determine. But what it ended up being was this stream of electrons that would travel across the tube from one plate to the other. And these electrons were actually coming from the plates there. They glowed because of the gas inside of the chamber. Now, what happens under normal conditions, like I said, it'll go straight across. But if they found that if they put a magnet close to the tube, they could get the particle of electrons to bend one way or another. And depending on what side of the magnet that they used, it would either push towards the magnet or away from the magnet. Ultimately, what they found is that putting a negatively charged item close to this stream pushed that stream away. This told them that this stream was made up of negatively charged particles. So they know that there's some particles that are being given off by this metal plate, which is made up of one type of atom, and it's negatively charged particles. So at this point, they know that electrons have a negative charge, and they want to know if this is the case in every atom. So they use different types of metals in the cathode ray tubes, and they just get the same results. So all the different elements that they use, different metals, give the same kind of results. So they said, okay, all elements or all atoms have, at least part of it, have this negatively charged electron. Okay. Now they know that there's a negatively charged part of the atom, but they also know that atoms are neutrally charged, meaning they don't have a positive or negative overall charge to it. It's neutral. But if there's a negative portion of the atom, then they knew to balance that out, there must be some kind of positive portion of the atom. And later on, we would find out that that's the proton. But at the time, they didn't know what this was. So there has to be some kind of a positive to balance out that negative since the overall charge is neutral. So they've got a little bit of information there. They want to go a little further. Then they start looking at the mass of atoms. So it was easy enough to get the mass of an atom. They didn't have trouble with that. Then they started to look at the individual mass of electrons. And what they found is that the electrons only made up a small fraction of the mass of the overall atom. So it was making up a tiny portion of it. What their model turned out to be, what they took from that, was this model here, which is incorrect, by the way. It's just leading up to our current understanding. This is not an accurate model of an atom. But their suggestion was that there's this large mass of positively charged stuff that makes up the atom, and embedded in it are these very small negatively charged electrons. So these are the things that they concluded from the evidence that they had at the time. This model was called the plum pudding model because they're English or something. And again, this is not our current understanding of what the atom looks like, but this is how things in science work. You build off the evidence and you build off from one model to the next, slowly refining it. All right, thank you very much.